The speed or the velocity of change is incredible. You're going to get a long-term reliability. It's like a passenger vehicle on steroids. Silicon carbide is the backbone of that.
Seems like a no-brainer, doesn't it?
Yeah.
Hello and welcome to ipXchange. I'm here today with Guy Moxey, VP of Power Development at Wolfspeed, one of the world's biggest makers of silicon carbide chips. So we're here to talk to Guy about mobility and the future of mobility over the next 5, 10, 15, 20 years. Guy, welcome to ipXchange.
Pleasure to be here yet again. Thank you.
Absolutely. So some of you will have seen a previous interview with Guy talking about the looming crisis of energy generation. Urge you to go and look at that. It's a really interesting chat that we had. Today, though, we're focusing on mobility, as I say. So we're here in Munich. It's actually the eve of Electronica, so that's the world's biggest trade show for the electronics industry. So it's interesting. We've been driving around on the roads of Munich already. So for all of the talk of climate crisis and the need to address the problems of carbon emissions from the mobility sector, which is about 20% of global emissions, and 3/4 of that is road transport. Here we are in Munich, and still the majority of cars fueled by petrol, by diesel, by gasoline. You see some Teslas, you see some BYD cars, but most of them are driven by fossil fuels still. So, Guy, if I could sort of start by asking you, you're sort of working at Wolfspeed, so you're engaging with many of the world's biggest manufacturers, including automotive manufacturers. So you see a little further out than most of us have the ability to do. What can you see sort of coming down the road, sort of technologically and economically, that means that in 5 or 10 years' time from now, what we see on the roads of Munich might be very different from what we see today in 2024?
I certainly hope they are. We're definitely in a time of change. Wolfspeed silicon carbide is being absolutely bear hugged by the automotive industry. And this is new automotive. This is not body electronics and window wipers and stuff that's been around for a while.
So you're talking about traction, you're talking about the electric motor.
We're talking about BEVs, the true turning of the wheels and the charging, the electrification. So, and it's an interesting time because wind the clock back 6-7 years, when it first started to go, there were electric vehicles around.
Yes.
Weird armadillo-looking like things, which were powered by silicon. Silicon carbide comes along and enables a better performance of car. Not speed performance, that's what we normally think about performance, don't we? Brake horsepower or 0 to 60, but we're talking here range.
Yeah.
Range or cost. So silicon carbide is the enabling factor for that. And it was almost like we were crushed in the tsunami of interest. But design cycles are very slow, and we've seen some twists and turns in the last year in particular. And you're right, we're sitting here in the heart of German automotive.
Yeah, in Munich,
and you're absolutely spot on. You see 1 in every 20 maybe cars on the road that are electrified. I was in China last week, and it's completely the opposite. If you look at China pre-pandemic and post-pandemic, pre-pandemic, especially if you were in the south, you saw quite a few BYDs knocking around. The taxis were BYDs, but they were in the minority. Last week, and I've been a couple of times, over this last year, I would say in the tier 1 cities, 60% of cars on the road are EVs. And you can tell because the number plates are green. Yeah. So it's very easy to identify. At least 60%. So that's a dramatic change. And China has the ability to implement things quite quickly, as we've seen. Whereas Europe and North America take a little bit longer. But,
and I guess China has, in this sense, the advantage of having been industrialised much later than Western Europe, than North America. So, there's less sort of an installed base of the old fossil fuel infrastructure and vehicles themselves, of course.
And as a nation, they want to prove themselves to be green. And ahead of the curve. So it's very interesting to see. Right now it's a little bit of a slowdown on EV, so we hear in Europe. Who knows what's going to happen in North America? due to recent events of last week.
Donald
We'll
Trump
see.
just having won the election to
We'll see.
become president.
Yeah.
Yes, yeah.
We'll see. But the overall charge has to keep on going. We can't keep spewing out CO2 and nastiness from exhaust pipes.
Yeah, absolutely. So you're obviously seeing that very closely from a silicon carbide point of view, which delivers important increases in efficiency and helps to lower the weight, reduce the size of the power system in electric vehicles. So that's really important technologically. What else is happening from what you're seeing in China, if you like, as in the vanguard of this? Technologically, that's really driving that fast growth in EV adoption in China. That's coming to the rest of us.
I mean, it's a real teamwork, because silicon carbide are the power transistors that drive the inverter to turn the motor. We're the nuts and bolts, right?
Yeah.
Battery technology has come on leaps and bounds in so many ways, and there's so many different chemistries coming out, and the traditional fear of rechargeable batteries after so many cycles, they lose their charge. But the different chemistries are coming out. The controller guys, the digital guys, the functional safety that has to go into these cars, the sensing for autonomous and that type of thing. So the whole thing has to come together.
Yeah.
And we're seeing each 2 years a huge advancement in all of these technologies, and that's what's enabling it.
Yeah. So there's a technological story there. Clearly, China, in one way or another, is making the finances, the economics of it work. So, as you were describing, been massive and rapid adoption of electric vehicles. So both of those things are tailwinds pushing us towards this. To what extent is government intervention also an important part in the electrification of road transport?
It definitely seems to be in the mix.
Yeah.
I would actually venture about the charging infrastructure.
Right.
We hear that's one of the big headwinds, and it certainly is. I was reading some stats around Germany as we're sitting here, that if I can, don't quote me on the mathematics here, but let's say there's 30 million electric cars needed on the road by a certain date.
Yeah.
There's not the gigawatts of energy available to charge them.
Yeah.
For a start off,
which was part of what we were talking about in the other video,
the energy deficit.
But absolutely, yeah.
And then even if there was the grid, the utility in gigawatts or terawatts available, then how do you actually dispense it on the infrastructure?
Yeah.
Because I've never gone to a planning department in Germany, but I can't imagine a planning application is that rapid in Germany. It's certainly not in the UK, is it?
Indeed, yeah.
Where because you've got to install this stuff, and so it's the government there can make a huge step in, not just on incentives and tax refunds and that type of thing, but the infrastructure's got to happen. And in Germany, or in Europe in particular, it's absolutely critical, because China, it's very inner city driven. You're not driving from city to city. Whereas obviously in Germany, France, UK, etc., you are driving between cities on a very regular basis. So you've got to have that infrastructure. Which again leans on technologies like silicon carbide. So it's we're quite motivated for all this to happen.
Yes, because obviously you're in the charging part of the system,
nuts and bolts
as well as in the individual automobile itself.
Exactly. Yes. Yeah.
Absolutely. Okay. Good. Well, so you were describing, as you say, there's intra-city mobility. So driving inside the city, there's city-to-city transport. In China, which is a huge landmass, same in North America, the distances are enormous, and people are not always doing that in their car. So what about the other modes of transport? So air transport, rail transport. What are we seeing there then in terms of electrification? Because that sort of seems a lot harder, because we're dealing with much bigger vehicles, if you will, and so everything becomes, you have to scale everything up. It's much more difficult, isn't it?
It's true to a certain extent, but the same principles of a four-wheel passenger vehicle ring through on everything. It's about more efficiency, so more range, more use time, or power density. You want smaller, lighter blocks of power. So the principles are all the same, and this is off highway. The sector's called CAV, construction agricultural vehicles, is a huge area for electrification because the emissions come from those are massive.
Yes.
You think about trains though as well. They've been diesel or diesel electric or fully electric for many years. So there's a principle of mobility, and then things that fly in the sky and things that bob around on the water.
Yeah.
Over this, you said it, Tim, this next 5, 10, 15, 20 years. So this is a multi-decade transformation, and again, the speed or the velocity of change is incredible. Hats off to the Chinese again. eVTOLs, or the various types of electrical vertical takeoff type variants, not just a VTOL, a CTOL, an STOL.
Yeah.
These flying taxis.
Yeah.
I was reading in Shenzhen already there's 240 vertiports established. So a point of takeoff and landing. 240 of them in the city already.
Yeah.
With a fast, with a megawatt fast charger, ready to go.
And what's the mode of use for these then? Are they operating as like an Uber, like an ordinary taxi? Is that?
I believe so. I mean, they're not happening yet, but I think in the next 2 years they are. I mean, whether it's Europe, North America, Asia, they're all getting their flight certifications, which makes them ready to go.
Yeah.
And from what I'm seeing, from the designs that we see, it seems like the sweet spot seems to be sort of across city.
Yeah.
So relatively short, point to point.
So up to sort of 20 kilometres, that sort of
I would
distance?
say maximum, yes.
Yeah.
Carrying 4, 5, 6 people, point to point. So let's take Newark to Manhattan. There's a classic. Take you an hour and a half in the car.
Yeah.
And probably cost you $150 maybe in a taxi.
Yeah.
Certainly you land in Newark and you want to get to Manhattan, and 8 minutes, 10 minutes, you're there.
Yes. Yeah.
So that's the perfect type of scenario. Shuttling, multiple trips a day.
Yeah.
They know exactly. And even if, let's get really clever, that's the perfect thing for autonomous as well, isn't it? Point to point. They know exactly the route. It's limited on height, so the airspace is clear. And so you think, well, the first step is piloted, but it's not too far away before it becomes autonomous.
Yeah, it's extraordinary, isn't it? Because I think even perhaps 3 or 4 years ago, I think the idea that you might have had electrified air transport of any kind was
it was science fiction movie.
Absolutely, yeah.
It was, but no, I've sat in them. Not flying, but I've sat in them in their demo spaces and stuff, and they're here. They're here.
Yeah, absolutely.
I mean, that's just a taxi, but you mentioned boats. There's a huge move for electrification of large cargo ships, not just pleasure craft, because the amount of emissions come from those are incredible.
Yep.
And 80% of the world's goods are shipped by water anyway, and then stuff off highway. Ranging from combine harvesters to tractors to even, here's one, a mining truck.
Yeah.
So it's not particularly green, digging holes in the floor, but you've got to get the lithium and cobalt out somewhere. And these
for the batteries,
these things are the ones where the tyres are 10-foot high, diameter.
Yeah.
And they spend 95% of their time at idle, at tick over, spewing out diesel.
Yes. Yeah.
So electrification of those is prime.
It seems like a no-brainer, doesn't it? And so all of these, so the marine transport, the off-highway, the CAV, as you were saying, these are all in one way or another being powered by battery energy storage.
I mean, you can throw in some fuel cell.
Yeah.
But the majority will be battery. So it's like a passenger vehicle on steroids, and that's even better for silicon carbide because the bigger the power, the higher the voltage.
Yes.
Some of these things. You look at a boat or a mining truck. These are megawatts.
Yes.
They're not just a 150 kilowatt small passenger vehicle. These are megawatts.
Yeah. So, from the point of view of your customers deploying your components in power systems, is it just a matter of scaling up? So, from a small passenger vehicle up to that huge mining truck with the tyres taller than a person, it's just a matter of scaling up.
In essence,
Yeah.
yes. I'm not a designer of a mining truck, so I don't want to be dismissive of that. But in essence, it is. It's it's a battery inverting the DC to create sinusoidal ACs to turn a motor. Now, the different scale, they might have multiple. They will have multiple motors rather than one single one. They could be in axle. Don't forget, it makes it quite interesting. If you're flying a taxi, you've got altitude considerations. If you're on water, you've got humidity considerations. If you're off highway, you've got shock and vibe and all those sort of nasty environmental considerations, which are a little bit more harsher than say a car. So you've got to factor in those. But the principles, the power electronic principles at scale are very similar.
Absolutely. So do you foresee any problems in the rollout of this electrification technology across these sectors from the supply chain? And I mean that broadly. Obviously, you've got very, very good insight into the silicon carbide supply chain. But that, and then more widely, I mean, we talked about mining lithium and cobalt for battery materials and so on. All of these issues, we're talking about a massive scaling up of technologies that have not been deployed on this scale ever before in history.
I would think there's going to be some challenges, and that will be some headwinds. Yeah, I would probably think the battery side of life, and I'm going to see a few battery people at the show, the Electronica, and get the pulse of what that is, because it's not an area I'm in, but none of this is going to move without a battery. From a silicon, from a controller, from the brain point of view of a car, the silicon, I don't think is going to be that constraint. Silicon carbide, we know everyone's investing, and the rest of it, not being dismissive, is more nuts and bolts traditional automotive anyway. So I think a lot of this hinges around the battery chemistry and technology and availability and cost as well.
Yeah. We've talked about the way that China has adopted EVs at an incredibly fast rate, and that's visible on the roads today. Europe, North America, other parts of Asia, nowhere near that speed of adoption up to this point. Do you think that the industry in Europe, in North America, in Japan and Korea, is responding fast enough? Are there other different things that they need to do to better adopt or faster electrification technologies?
They could always do better. I think let's think of it as a consumer. Let's if we can, turn the question around. What are we looking at as a consumer? Cost of a vehicle. Yeah. And the cost is higher than the traditional vehicle at the moment, but although we're seeing some manufacturers come in with very aggressive costs, the quality of these machines are incredible now. It's going to be interesting to see the mindset of brands. You and I are a particular vintage where our dads can remember Datsuns coming into the UK, and everyone was
Japanese manufacturer.
Exactly, yes, load of rubbish.
Yes,
everything's perceptions of reality. A load of rubbish compared to a British Leyland Morris Marina. Wouldn't say that, but there's going to be a flood of new brands, global brands coming in, not only from China, but
elsewhere,
Southeast Asia, various ones, and so going to be interesting. It's going to shake the market up. But from a consumer point of view, unless you've got a particular brand loyalty, some people have, some people haven't. They want a good quality of product at the right price. And reliability. That's an interesting question, because I'm hearing, 1 million kilometres, 1 million miles is the lifespan. You're going to maybe go through a battery or two, probably, but the number of mechanical parts is a lot less. A motor is inherently more reliable. An inverter is pretty reliable. So, you're going to get a long-term reliability here. So the ROI is a different way of thinking as well.
From the consumer point of view.
Correct.
From the manufacturer's point of view, then they're going to see the purchase and replacement cycle slowing down. I mean, is that potentially a problem?
It's a different approach. It's a different approach.
So I'm sure manufacturers will be looking at maybe mobility as a service as a way of trying to maintain their return on their investment in new model development, because their replacements will be less frequent.
Or even you're seeing some already where you buy the vehicle but rent the battery. And then you swap out the battery. Even instead of charging, you do a battery swap. And if you know you're going to be in your city for the next 2 weeks, you swap out for a lower kilowatt hour battery, and it's a cheaper swap. If you know you need to drive a little bit further on a family day out, you go and swap the battery in about 8 minutes, by the way, allegedly, for a higher kilowatt hour battery. It's great. It's a great approach, isn't it?
Yeah, absolutely. So much change going on, isn't there? One area in which there's not so much change is in America. The government is going to go back to we're going back to the future, back to 2016 with the election of Donald Trump coming into power in 2025. Do you foresee that having a significant impact on the rate of adoption of electrification generally in electric vehicles, also elsewhere? He's professed some antipathy towards the Biden administration's attempt to push a green agenda, and has been very keen on supporting the fossil fuel industry in America. Do you expect to see some difference in the rate of electrification with a new government?
There's a distinct possibility. I mean, I'm no political commentator, but obviously I have a vested interest in things green because we make efficient power semiconductors. America's a tough nut to crack. Their love of the big truck and the V8 motor is inherent. But the new president seems to be very good friends with Elon Musk. So there's a vested interest for electric vehicles for a start off. So I'm hoping that America still makes a stand on green, and not just EVs, but the drill baby drill thing is a lot more fossil fuel, and there's plenty of wind. There's plenty of wind going around in North America right now.
And lots of new solar power generation happening as well. So
we talked about it in our previous interview. You can't just flick a switch and go green anyway. It's a transition. It is a transition. So I hope America carries on that route of transition, because it does give jobs. That's true. It creates jobs. So I think there's a blend, but America needs to show a leading light on this one.
So regardless of the potential wobbles over the next 4 years from 2025 with a change in government, you're still confident about the future for the silicon carbide as a sector for a part of the electronics industry?
Oh, totally confident, and so is the rest of the market. We're just switching on our latest fabs, fully qualified and ramping. Our competition are putting the rooftops on, putting the infrastructure in on their new fabs. So everyone's investing on this continuous wave. Yes, as our CEO said, there are some twists and turns, always are. It's not a hockey stick all the way up. But electrification of everything is happening, and it's got to continue to happen. We talked about then you need the green energy to power those batteries. And then you need, developing the grid infrastructure to cope with that as well. This is, the multi-decade opportunity of mobility, which we've just been talking about, is backed up in parallel with the multi-decade opportunities for just generating and using renewable energy in a better way. And silicon carbide is the backbone of that. Not the sexiest bit of it, but it's the backbone.
But really important.
Absolutely.
Very good. Thank you, Guy, for joining us today and giving us your thoughts on ipXchange.
Absolute pleasure to be here, and enjoy the show.
Thank you, and you.
Thanks. Bye-bye.